starting here at the top of page 3 for 9.1, just a little direction for where you can find these reminders in the book. On page 551, they go over the definition of a principal square root and also the nth root of a real number. And again, they're reminding you that that's called the index. So we've just been focusing on square roots, but you can put any number there and find a root. And that's what we're going to focus on next. I'll go ahead and move the camera to hit the bottom of this page. And sorry about that. And we'll do some of these examples together. So starting at number 48 on page 556. So now this is known as the cube root or the third root of 27. So now what we're looking for is something times itself again that will give us 27. So again, all three have to exactly match. Same thing applies here in terms of the positive. This is the principal cube root that we're looking for here because there's no negative out front, it's just a positive. So what times itself? And again, if you took the time during the factoring chapter, chapter 7, especially when we were dealing with the difference of squares, sum of cubes, difference of cubes formulas, the suggestion was to really get familiar with what those perfect squares and perfect cubes were. And just as a helpful hint here, we've got some of the perfect cubes and the perfect fourth roots and the perfect fifth roots. So you can start to get familiar with a few more numbers because time is of the essence during a test. You want to recognize, yeah, I know 27, that's a perfect cube. 3 times 3 times 3 is 27. So the cube root of 27 is positive 3. Moving on to number 52, the difference here is this negative out front, okay? So the negative out front really means that you've got a negative 1 times the cube root of 27. So cube root of 27, we know it to be 3. So the answer here is just negative 1 times 3. That answers negative 3. On the cube root of negative 27, what if it looks like this? Okay, when it was a square root, we could not find something. We couldn't find a real number because something times itself couldn't get you back to a negative. However, it's okay to find or to take, that's the terminology, to find or take odd roots of negative numbers. Why? Well, in this case, it's a third root. So we're looking for something times itself 3 times that would give us a negative 27. Okay, it won't be a positive because positive, positive, positive would still give you a positive. But if you take a negative, and again, all 3 have to exactly match. And hopefully you're catching on that it would be a 3 involved because that's what how we get to 27, multiplying a 3 times itself 3 times. If you make all of these negative, negative times a negative is positive, times another negative is going to be negative. So negative 3 is your cube root of negative 27. So this answer is negative 3. And sorry, I kind of ran out of room there, but our answer here is negative 3. Let's look at number 60. We did cube roots. Now you get to practice with some fourth roots. Square root is the second root. Cube root is the third. This one you would just call the fourth root. And beyond that, you just call it by the number. Fifth root, sixth root, seventh root, eighth root, that kind of thing. Okay, there's no special name like square and cube. Okay, so what are you looking for the fourth root of 81? We're looking for something times itself 4 times to give you that positive 81. And again, there's no negative out front, so we're just going to leave it as is. So these all have to exactly match. Again, you want to get really familiar with it. If you don't remember, you blank a little bit, you have not gotten yourself really familiar with this list, in this case you're going to want to know that 81 is your 3. You can get to it. You can go ahead and jog your memory. You could say, okay, well, what do I know about 81? Well, I do know that it's 9 times 9, And then 9 is 3 times 3, and another 3 times 3, and there is your thing there. 3 times 3 times 3 times 3 gets you to 81. So this is, the fourth root of 81 is 3. Now what about the negative fourth root? Okay, so when you have a negative out front, this is critical. We wrote this in our I can list. This comes into play so many times in algebra. You really want to get this in your head. With a negative out front, what it means is negative 1 times whatever you're dealing with. It's negative 1 times the fourth root of 81. So that negative 1 just stays as is. We know the fourth root of 81. That's just 3. So then the answer is negative 3. Okay, when we had cube root of a negative number, it was okay, because a negative times another negative gets you back to a negative. When we had square root, it didn't work. Our answer was not a real number. What do you think we'll have when it's a fourth root? Because again, we're looking for something times itself 4 times. All 4 have to exactly match. Now we know the fourth root of 81 is 3, but how do we get negative 81 out of that? Well, it can't be done, because all positives would give you a negative, and if you were to put 4 negatives in here, the 2 negatives would give you a positive, times the third negative would give you a negative, and then your negative times that fourth negative would give you back to a positive. Or you could think of it as 2 negatives give you a positive, the second 2 negatives give you a positive, and positive times positive gives you a positive. So this is not a real number. Okay, so can't find a real number answer to even roots of a negative number. Okay, so it's okay to take odd roots of a negative number, third root, fifth root, seventh root, 19th root, but even numbered roots, square root, which is the second root, fourth, sixth, eighth, 10th, all those of a negative number, jump right to this is not a real number. Okay. So take a moment to copy all that down for yourself, talk it through with somebody, make sure, or even just out loud for yourself, and bring your questions to class. That's what class time is for. And then as our bottom one, we don't have a try for you right now, but on page 54, there's the little chart. Some familiar cube roots, they take you all the way up to 6 cubed, or the cube root of 216 is 6. Fourth roots take you all the way up to fourth root of 625 is 5. And the fifth roots, fifth root of 32, fifth root of 243. Be very, very familiar with these. Look at these often, put them on a post-it, record them onto something and listen to them. Just remind yourself, talk them through. That way when you see these numbers on the test, they alert you, oh, I've got one of the, either the perfect cubes, perfect fourths, or perfect fifth numbers that I can quickly find the root of. Okay? Saves you a lot of time on those exams.